Now, we've talked about long division. I do want to talk about a shortcut. Long division always works. It is long division. It works numbers, variables, polynomials, doesn't matter. Long division is always going to work. It is a great way to use. It is not the quickest way always, though, because you do have to repeat over and over until you finish carrying down. There are some special circumstances where we can do it quicker if we use another method. It's just that it doesn't work all the time. It only works in certain circumstances, and it is a shortcut. That shortcut is called synthetic division. I want to point out it is a shortcut. However, because some of these problems we're going to have to do division several times, having a shortcut and a quicker way to do things is actually a great idea. If I were going to divide a problem such as this, and I was just going to use long division, I would have to say, okay, I'm dividing x plus 2 into, seeing how many times it will go into, x to the fourth minus 6x squared minus 27. The problem with this particular polynomial is that it's missing terms. I've got x to the fourth, but I don't have an x to the third term. Polynomials really should count down and have all the powers from the highest one all the way down to the bottom. So when you are missing a term, you have to use what we call a placeholder. So I'm going to put in the place of x to the third a 0. X to the third. If you don't do that, when you're doing the long division process, things don't line up right, and you start trying to add and subtract terms that are not the same, and that causes a lot of drama. I do have an x squared term, so I can do minus 6x squared. I do not, however, have an x to the first term, so I'm going to use another placeholder, 0x, and then I've got the minus 27. So when I do my long division, it's the same process as we talked about previously. We're just going to have these placeholders here to make sure that our answer turns out neat. X to the fourth divided by x is x to the third. When I multiply x to the fourth, 2x to the third, I'm going to subtract everything, so those cancel, and I end up with negative 2x to the third. If we had not had this placeholder here, we'd have been trying to put x squared and x to the third together, and most people don't pay attention, and that causes a lot of headache. So having these placeholders is extremely important. Carry down and repeat the whole process over again. Negative 2x cubed divided by x is negative 2x squared. I'm going to distribute negative 2x cubed and negative 4x squared. I'm going to subtract, so minus a negative is positive, minus a negative is positive. Those cancel. This gives me negative 2x squared, and carry down my placeholder. Repeat. This is going to give me negative 2x this time. I get negative 2x squared and negative 4x minus a negative minus a negative. Cancel. I get 4x and carry down for one last spin around the block. And I get 4x divided by x is just going to be positive 4. It's going to give me 4x plus 8. Subtracting, so I'll subtract both of those. That'll cancel. Negative 27 and negative 8 is negative 35, which is my remainder. So I'll write that as a fraction, plus negative 35 all over x plus 2. And so that would be the long division for this particular problem. What I would like to show you, taking up a lot less space and a lot less writing, is the process called synthetic division. What you need to know about synthetic division is that it is a shortcut, which means you have to be very careful. It doesn't work all the time, and if you try to make it work in a circumstance where it's not supposed to, that's where you start to have a lot of problems. You can only use synthetic division if your divisor, what you're dividing by, is a linear factor. It's got to be x plus or minus something. So x minus 3, x plus 10, no x squareds, no x cubes. It's not that it's just a binomial. It does have to be a linear factor. So we talked about linear factors the other day. It has to be x plus or minus something. So we want to make sure that it is a linear factor. And as long as it is, we can use synthetic division. All you're doing with synthetic division is you're basically not writing the x's anymore. You're just dealing with the coefficients and the numbers. And that way you can use something like a calculator to just do the arithmetic, to do all of this divide, multiply, subtract, that kind of stuff that's going on here. And then we can put the variables back in after. So you see all this work we did for long division. If I was going to do this for synthetic division, I kind of want to use the same division bar, but I'm going to turn it upside down. And what I'm going to do is on the inside, I'm still going to write my dividend, but I'm losing all of the x's. I'm just writing coefficients. So when I look at this problem, I do have a coefficient of 1, a coefficient of 0. Folks, these placeholders do still have to be there. Okay? In synthetic division, it's even more important, because if we leave them out in long division, we might notice that that's x squared and that's x cubed, and I can't add those together, and I can still get the right answer. But in synthetic division, if you leave the placeholder out, you add and multiply incorrectly, and it does change the answer. So make sure you include the placeholder coefficients. I've got a -6. Negatives do matter. I've got another placeholder of 0, and I've got a -27. So I lost all the variables. I just used the coefficients. What we put on the outside is our divisor, what we're dividing by. But again, we're going to lose the variables. We're really only interested in this number. And because of that subtract step in the long division, since we know that we're going to end up subtracting it, we're just going to go ahead and make it the opposite sign. If it's plus, I use a -2. If it's a minus, I use a +2. So I do want to make sure that I always use the opposite of that number to go right here. And then it is just a matter of following a simple procedure of dropping down the first number. You're not going to change it. And then we are going to multiply and add. We're going to repeat, multiply and add over and over and over again. So drop the 1, and I'm going to take this outside number. You're always multiplying by this outside number. -2 times 1 is -2. Add. 0 plus -2 is -2. Multiply. -2 times -2 is 4. Add. -6 plus 4 is -2. Multiply. -2 times -2 is 4. Add. 0 plus 4 is 4. -2 times 4 is -8. -27 plus, we're adding, -27 plus -8 is -35. So you will always multiply, and when you multiply, you put your answer up here, and then you are always adding up here. So I multiply, put my answer there, multiply, put my answer there, and I add coming down. But notice what is similar in these two. This took up like 3 lines of work, whereas this one took a lot more than that. But look at our coefficients. 1x cubed minus 2x squared minus 2x plus 4. When you're doing synthetic division, this last number always turns out to be your remainder. So if you ever get a 0 in that spot, that means that you had no remainder. It divided evenly. But when you do get a number in that spot, it is your remainder. Now, again, this is a shortcut. This is not my answer. I can't leave this as my answer. But it's going to give me my answer. I just need to put my x's back into it. Well, if we started with x to the 4th and we divided it by x, that means that our answer is always going to be 1 less than what we started with. X to the 4th divided by the x is x cubed. So that means that I'm going to start with x cubed, and then x squared, and then x, and then the constant, no x, and then our remainder. So when I write my final answer, I have 1x to the 3rd minus 2x squared minus 2x plus 4 plus my remainder of -35 over x plus 2. So synthetic division can get me the same answer, just a lot fewer steps.